with your periodic table, the one I gave you, the plain Jane, we need to modify it. Right here. How many elements are in that top row? Two. Which means you could have a maximum of how many electrons in that first ring? Two. So when you are modeling, okay, if we're doing a Bohr model, where's my black? Here we go. If I'm doing a Bohr model of whatever element it is, if it's that first ring, so hydrogen or helium, it would have one ring, and you'd have one electron for hydrogen, so that would be hydrogen with an H in the middle, or it'd be two electrons and it'd be He, helium. I've also seen Bohr models where they just put both of them together like that. Okay, I would accept either one. I don't care. All right. In the past, I've even told people, especially when you get to a larger model, you could just put a number 2 on the daggone ring, and I'd be like, got it. There's 2 electrons there. Does that make sense? All right, I'd take that. So that's the first row of the periodic table. On your periodic table, right here next to that box, I want you to write the number 2. Kind of right next to the number 2 that's in the box, just to the outside, write the number 2. What that's going to mean is for either of those elements in the first row, there's going to be a maximum of 2 electrons in that first ring. Okay? Does that make sense? Because hydrogen has 1, but could it ever have 2? Yes, it would be an ion. Right? Okay. Everybody good? That first ring represents the top row in the periodic table. Understand? It can have a maximum of 2 electrons. Okay? And you know what? From here on out, I'm just going to put the number. Especially since it'll probably show up better on the camera. Okay? So, first ring, 2. Yes. Helium. Right here. Let me move this over. Right here. You're going to put the numbers I'm describing to you. Pen. Here we go. 2. All right. Well, that's gigantic. How do you make it smaller? Pen. I can change my color. How do I change the size? I don't know. Anybody know?
Try that one. Yeah. No, that's it.
Anyway, so I put a 2 there. All right. The second row on the periodic table has how many elements? 8. The second ring on your Bohr models corresponds to the second row on the periodic table. So 8 elements, max 8 electrons. 8. But check it out. The first row is still there, isn't it? For the elements in the second row, they still have the electrons that were represented by the elements in the first, right?
Yeah.
So the first ring is going to have 2, and the second ring is going to have 8. Man, I really can't draw with this gigantic marker. Like, it's a pen, but it's huge. Fade timer? No. Whatever. I really wish it had a slide to adjust the size. Cool. All right, is it? Yes.
So it's just like how many are each row as how many they can go in?
Maximum, yes. So for example, let's do an example. Lithium through neon is the second row, yes? All right. Lithium would have 2 in the first and have just 1 in the second. That would make it lithium. Now, if I had, well, we already did fluorine, didn't we?
Yeah.
Fluorine would have 7 in that second row. But remember, the row can take up to 8. So fluorine could also have 8, and that would make it a -1 ion, right? Okay. So maximum for the second row would be 8 electrons. Does that make sense? Okay. Let me erase this because it's a mess anyway. Okay. Now, third row represents, or corresponds to, I guess I should say, the third energy level, the third ring, the third orbital. How many elements are in the third row? 8. So it also could have a maximum of 8 electrons. So check it out. This is for this one right here. I'm going to draw an arrow, okay? So for this row, you can probably fit those right here, okay? If you can fit it right next to that box, you're going to have to write a little smaller. You'd have 2 in the first ring, up to 8 in the second, and up to 8 in the third. Does that make sense? You'd put those numbers right here, 2, 8, 8. That's a maximum. First 3 rows in the periodic table are simple that way. You just go to the next row to add, to continue to add. You do your 2, then you do your 8, and then you fill out your 8 in the last ring. It starts to get complicated in the fourth row. Okay? Hopefully this makes sense to you. I'll do my best to explain it. Again, I'm not a chemistry teacher. Okay. For the fourth row, they need to let me change the size of the eraser too. For the fourth row, you'll write down next to it, try to keep the numbers right here, it'd be 2 for the first row, right? How many for the second? 8. How many for the third? 8. How many for the fourth? 18, but hold on. If I've mentioned this before, I'm pretty sure I have. The valence shell, the outermost shell, can only take up to 8. So the outer shell is going to be 8, but wait, we need to have up to 36, which means this next row back would take the 1. Why does everybody want to distract class right now? Okay? So let me restate this for you, okay? The fourth row gets a little complicated because you can't have more than 8 in the outermost ring. Let me do it this way. So you'd have 4 energy levels because we're in the fourth row. Follow. So we're going to fill up 2 in the first, 8 in the second. We'd have 8 in the third. And we can only put up to 8 out here. After we hit 8 on that one, the remaining electrons go back on this one. So there's 10 left to be placed, so it'd be 18. Does that make sense? Kind of, sort of, maybe. We'll do some examples, okay? So next to krypton, you'd write 2, 8, 18, 8. Okay? Eraser. I need a bigger eraser. This is nuts. And a smaller pen. Okay, now for xenon's row, all the way back over to rubidium. How many do you think the first row would take? 2. How many do you think the second row would take? 8. How many do you think the third row would take? Up to 18, right? How about the fourth? Also up to 18, because there's 18 across in those 2 rows, right? But you can't have them in the outermost shell. So we're in the 1, 2, 3, 4, 5th row. So that 5th ring would have up to 8. Okay? What? Sure, take the pass. All right, so everybody got those written down next to xenon? 2, 8, 18, 18, 8. Guys, remember, I'm not going to hold you to knowing anything past the first 3 rows because it's simple in the first 3 rows. It gets more, you take more practice, and we don't have time for that. This is not a chemistry class. I'm just giving you a taste of it, all right? I'm only teaching you what I need you to know for this class. We don't really need to know past there. All right, can I erase this? Okay. Find my tiny little eraser here. Good grief.
Yeah, it's funny you erase your big marker.
Yeah. Okay. Goodness. I need to give them feedback. All right. All the way down to radon now. Okay? Radon. How many in the first ring? 2. Second. Third. 18. Fourth. I'm looking at my cheat sheet back there. No, it's going to be 32. And then it will be 18 and 8. Whoa, 18. So 2, 8, 18, 32, 18, and 8. Where did the 32 come from? The reason you say you're confused. All right, look up here. Do you see these two series here? Lanthanide and actinide series. Okay, they're named for the first element in each of those series. All right, these two rows plug in. Do you guys see right here? You see that? This one plugs in right there. This one plugs in right there. Got it? This whole row sticks in right here. Notice this ends with 71 right here. And this ends in 72. That whole row plugs in right there. Now, why didn't they just shove the rest of it down? The reason they didn't shove the rest of it down, look, you guys see these noble gases? The noble gases share characteristics. They've got a perfect electron configuration. Radon, as an example, fits that description. We want to keep families in that same row because they share characteristics. If we put that row in here and shoved the rest of them down, it would no longer line up. We want it to line up. So the scientists that know better than I determined, hey, we'll just show this as like a pull-out or whatever you call it, like an inset. Okay? And the same thing for the row here on the bottom, the actinide series. Does that make sense? Kind of, sort of, maybe? But there's enough there. If you count them up, it's going to add up. So all of these, plus the ones that are up here in that same row, it adds up to 32. Okay? All right. So next to radon, you'd have 2, 8, 18, 32, 18, 8. Make sense? Yes. Is the pass back? Every time. Guys, how does this work? The pass gets back. Go. If I care, I'd be like, where did he go? And then you'd tell me. But I understand that sometimes y'all need to go pate. Go pate. Okay? Just no parte in the pate. All right? Like, don't like, there and back. Do your business. Get back. All right. I'm going to do a lot of editing in this video because I'm talking about potty. This is chemistry. Okay, well, you have to. Now, guys, the regular chemistry in high school, they're probably not going to talk about all the exceptions to all these rules down here either, okay? That's more at college level, all right? So just don't freak out. All right, can I erase this? That is the question. Can I erase this? It's kind of difficult with this tiny little eraser.
Maybe you can use the roller and the mouse to make it.
Is that how it works?
I don't know.
No, I wish. All right. So, oh my heavens. Goodness. All right. Last one. Guys, last one. This is the most complicated one. So now we're all the way down here at whatever the heck that's called. I can't remember. So we have how many in the first ring? 2, and then
8,
8, and then 18. And I've got my cheat sheet on the back because I don't always remember. And then we go to 32. It'd be 32 again because there's 2 rows like that. And then it would be 18. And then it would be 8. 7 rows because this is the 7th row. So 7 rows, 7 rings. Okay? Whew! Now, that should help you understand where the electrons go. All right? So somebody give me one that they were struggling with. Nobody was struggling with anything. Okay. I have 1, 2, 3, 4 up there right now, so I'll be in the 4th row. Let's do krypton. We'll fill it all the way out. Okay? If I were doing krypton, what's with the extra talking? If I'm doing the Bohr model for krypton, the first ring would have 2 electrons. Okay? We're doing krypton. The second, representing the second row of the periodic table, there's 8 elements there. We'd have 8 electrons. The third row represents the third ring. There's 8 of them there. Okay, so we're going to start off by putting 8 here. 1, 2, 4, 5, 6, 7, 8. And then we can have up to 8 in the valence shell. Okay? But we're into a row now, right? Aren't we in a row that has 18? That 4th row has 18 elements running across. So you'd say, well, I need 18 here. But you can't put them there. It's the outer shell. You can only have up to 8. So let's go ahead and put 8 there. And how many would be left? We just put 8 of 18 in the valence shell. There'd be 10 left. Wherever would I put them? You drop back down to that last row before, right? And you'd have 18 there. So we had 8, 10, 12, 14, 16, 18. Okay? So now we can double check our work. Krypton is supposed to have how many electrons? Look at your periodic table. 36. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. And we didn't break any rules. We only have 8 in the valence shell. Make sense? That's how you do it.
Oh yeah.
All right. Now, stay where you are, okay? Stay where you are. Also, with all of this, like, can I restart? No, I don't want to restart the whole thing. Good grief. I want to, like, there should be a clear all button. There it is. Hey, that's nice. All right. Check this out. Do you notice there are colors here?
Yes.
There's yellow, there's like this bluish grayish, and then there's these red. This toolbar is covering up the key. Let me go up a little bit. There we go. The yellows are nonmetals. The reds are your metalloids. They're kind of like, depending on the situation, they might be more like the nonmetals, or they might have characteristics more like the metals. And then you have all the metals. This is the most basic color coding you'll probably find on periodic tables that have color coding, okay? Now, for the bonds that we've been looking at, so for molecular bonds, ionic bonds are between metals and nonmetals. Put that as like a note on the side. If you've got room somewhere, make that note. Nonmetals to nonmetals. So nonmetal N to nonmetal N, not nitrogen, okay, I know, I mean, that could be an example, are going to be covalent. That's actually kind of neat because this is the symbol for a covalent bond. So nonmetals to nonmetals is going to be covalent. I'm not going to try to write with this pen. It's ridiculous. Okay? Nonmetal to nonmetal, covalent. Metal to nonmetal, ionic. All right? So if you're taking nonmetals to other nonmetals, it's going to be covalent. If you're trying to bond the metals to nonmetals, it's going to be, I said I'm not going to try to write with it. It's very difficult. Ionic. To go from here, bond with those. Okay? Now, can you bond metals to metals? Yes, but it wouldn't be considered ionic or covalent. It's just called a metallic bond, because usually what you have is they get melted down and they form an alloy. And the electrons are shared like in a sea of electrons. They just kind of float, you know, they're shared amongst them. Don't get confused with covalent because that's sharing too. It's different. How much time do we have left? 4 minutes. Yeah, that's enough time. Let's do this. Can I erase this?
Yes.
Yeah.
All right. I don't think we have time. I really don't think. I was going to do, you guys want to try to cram it in? Yeah?
No.
You do, don't you?
No, not really.
All right, we're going to balance this equation real fast. How many hydrogens on this side?
2.
How many oxygens?
2.
2. Why did I say 0? I have no idea why I said 0. How many hydrogens on this side? How many oxygens? 2? 1. See, there's no number right here, but we have the symbol. So there's 1. Okay? H2O is water, right?
Yeah.
For every, guys, I don't have to shout over you. For every molecule of water, you have 2 hydrogens and 1 oxygen. For each molecule of H2, it's 2 atoms of hydrogen. For each O2 molecule, you have 2 atoms of oxygen. The way you can do this, you can't change the molecules, but you can change how many of them there are. So for example, people might be tempted to just say, well, I could put the number 2 here, and now I'd have 2 oxygens. But that means I just changed what the molecule is. H2O2 is not H2O. It's not water. It's hydrogen peroxide. Okay? So if you were like, oh, I'm going to have a nice glass of water, and you had H2O2 instead, you're going to have a bad day. Okay? It'll make you upset stomach at the very least. It can cause some actual real damage too, especially if it's not diluted. So you can't do that, but you can change the number of them. So I can put a 2 in front, and I say now we have 2 water molecules in the formula. 2 times 1 is
2.
So we fixed it. Oh wait, but now we changed the amount of hydrogens because 2 times 2 is
4.
so. But I only have 2 over here. So what do I do on this side?
Multiply them.
Yeah, I say there's 2 hydrogen molecules. 2 times 2 is, and we just balance the equation. Questions on that? You got like half a minute to ask questions on that. You good? You good? You what? You good?